So good afternoon to all of you. So I'd like to thank GIZ and USAID and MNRE and Ministry of Power to organize such a meeting. So because we normally, the meteorologists and people from power and from renewable energy, we do not talk so frequently. We don't know each other really. So there are many questions than answers. Why I am here? Because like in other sectors, as I am learning from since yesterday, that there is a very renewed enthusiasm in India to gain 175 gigawatt of energy and so on and so forth. In our Ministry of Earth Science, also there is a emphasis on improving the forecasting or bringing down the forecasting to improve the solar and to provide the solar and wind sector the meaningful meteorological forecast. So as a part of that, I will present some of the results here, which we have done since the last 1 year. But before that, I would like to mention a few things. Like, see, globally, forecasting low-level wind is considered to be one of the biggest challenges. You can't get any model at present, anywhere in the world, which can give you a very good, reliable, less error, wind at, say, 100 meters or 80 meters. Not even in the observations, unless otherwise you have a wind tower. So the fact is, we are going to address a very difficult, problem. And it's a very challenging thing. So having said that, let me go forward. Okay. So just as an introduction, just to make sure that we are on the same boat, we are on the same level. So what we do basically in meteorology or in atmospheric oceanic science or in geophysical fluid dynamics in general, and we are also mentioning about the uncertainties, we are mentioning about the errors and so on and so forth, why it is so much, affects the wind. So, this is the, we have 7 variables and 7 equations. And in principle, in mathematics, if you have 7 variables and 7 equations, you can solve it. One can solve it. But the problem is, here the equations are nonlinear. As a matter of fact, a small error in observation or in the initial conditions of any of these variables will affect the forecast, significantly. So this is concern number 1. Concern number 2 is from the questions on the previous speaker, we have come to know that people are asking about sand dunes, and also people are asking about the low pressures. And so this gives an idea that, that people, it involves many scales. It involves a huge, spatial scales, from large scale to a very small scale. Now to address that, you need to have a very fine, grid size. So in the horizontal as well as in the vertical. Now to achieve this, then along with that, you have this, physical heterogeneity, means you have all these, factors. Now all these things are to be represented in your numerical model in the most realistic manner. The more realistic these representations are, the better will be your forecast. So you can really understand the complexity of the wind. Okay. Now this is about the ocean. So the models are when we run, it also takes into account the state of the oceans, because it is an ocean and atmosphere coupled system. To do this, so all these observations in the space as well as in the oceans as well as in the land all need to be assimilated. So as a matter of fact, we depend on a very state-of-the-art assimilation system. So presently, there is a program under NITI Aayog. Okay, so there is a plan of developing a 12-kilometer global ensemble model for under NITI Aayog, and the purpose is that this model should be able to provide all the necessary guidance for all the sectors, including the solar and wind and, like agriculture and many others. So we are in the process of building that model, and the deterministic part of the model has already been built. It is tested, evaluated, and presently we have handed it over to IMD. And if you go to the website of IMD or even IITM, you can see the daily forecast based on this 12-kilometer global model. So what we do in this modeling system is this, that so these are different components, the observations, and then there's boundary conditions, and there's assimilations, and then forecast, and then we go to the predictions. Now let me go to, so this is the modeling system. So this is the assimilations is presently done in NCMWF, Ensemble Kalman Filter Hybrid data assimilation system, using all the observation that comes. In IITM, we run this 12-kilometer global model with 64 vertical resolutions. We run for the 10 days. It is somewhat similar to what the forecasts are being generated in TIGI by other global centers. And then and this is the resolution at which the forecast is being made available, 12.5 kilometers. Now, just before going into the solar and wind, I would like to give you a flavor that why we should believe this model. If you remember in recent last few days back on 29th of August, there is a very heavy rain over Bombay, and this model in real time we got this forecast here at Santa Cruz. I think the next figure will So if you see that actually the problem was in Mumbai the Colaba received around 100 millimeter, whereas this Santa Cruz reported something around 331 millimeter. So when we actually in real time when we saw, so the forecast actually could capture. See, this is IMD and this is GFS, and you can see the difference between this is Santa Cruz and this is Colaba. So this is the skill of the model at present in the real time, and this is the comparison with what the skill IMD was having was running the model earlier. That was the resolution of T574, meaning it was around 27 or 30 kilometer. Now this curve, even if you don't go into the detail, this is the kind of a skill, and this is different for different rainfall threshold. And you can see that this black curve, you see the solid curve T1534 for day 5. So that day 5 actually is coinciding with the day 3 of T574. It means that we have actually gained 2 days in terms of improving the skill by increasing this resolution to 12.5. Keeping this in mind, if I just compare the forecast in real time from the TIGI archive about the NCEP and ECMWF, two leading centers, and you can see the skills. This is for mean. So mean, forecasting mean is not an issue at all. What we want to forecast is the anomaly, is the disturbance, is the variations. Okay. So in that you see the skill comes down to around 0.2, and just by 25 millimeter threshold, both the model skill goes down to almost 0. So, okay. Now let me go back straight to, so this is the famous curve which I have understood. This is the power and this is the wind. So the point is once the wind reaches around 15 meter per second, then even if your model gives overpredict the wind, it doesn't matter, right? Because power becomes saturated. And if it is below 5, then also it doesn't matter. So what mostly matters is from 5 to 15, okay? And normally, all numerical model, they find it difficult to simulate or predict an atmospheric situations which changes very rapidly. And that is generic for all model across the globe. So that is why it is very challenging. But anyway, let us see what's happening. So this is one, case study, one test case, one Maharashtra. There were some sites, Palasbadi and Agasbadi, where we have a solar installations as well as wind power installations. What we basically do is that we use this GFS 12-kilometer model as an initial condition and boundary conditions, and then we configured the non-hydrostatic wharf at, we went down to 1 kilometer, and we used, several sensitivity studies, this thing, and finally, we took every 2 minutes just to make the, model forecast and the wind turbine apple to apple, because wind turbine also reports 10-minute data, which is the average of last 10 minutes. So what we did is the model output is every 2 minutes, and we make it 10 minutes and compared with the model and the wind turbine. And this is the the flow chart. What all we have done, several things. So the take-home message is, when we started our initiative with NCEP GFS, that time we got the correlation of the around 0.3. Then we used several land use land surface data from NRSC, from MODIS and USGS, and also our own this 12-kilometer model. Then the correlation coefficient improved to 0.7. That also was not up to the mark. And then we applied the bias correction using the turbine level data and computing the last, just like a linear autocorrelation, last 3 time steps error we used to correct the 4th step. So by doing that, we could reach to the correlation of 0.93. And I think, yes, so here you can see this is the percentage error. This is the line, I think, as per the MNRE, this is the 15%. So we have to be within that. So there are some places where it is going, above 15%. And if you see these curves, actually, so these solid curves are without bias correction, but this dash curve is with bias correction. So you see that, where there is a sharp increase of wind from, say, 6 to 12, the model normally is going flat. Okay, it doesn't capture the sudden change, whether it is increase or decrease. So there you need to do your bias corrections. So then only you can at the final stage you can provide the corrected forecast to the. But if you take with respect to installed capacity, error goes down. This is as per the exact, whatever is actually produced. Okay, here also it is the same. So this is, here it goes down, but with bias correction, we maintain the forecast. And this gives a reasonable value, okay? Now I just quickly show you what we did with the solar. Now solar, if there is, if it's a clear sky, the forecasting solar radiation is much easier than wind. Because everyday newspaper, it is written sunrise and sunset. Right, high tide and low tide. Because these are all periodic motions. You can forecast 1 year in advance. It's not a big deal. So if there is no cloud, solar radiation, the cycle of solar radiation forecast is not a big deal. But if there is cloud, if there is partly cloud, if there is rain and cloud, cloud and sunny, so many things, then questions of your model, uncertainty and accuracy will come into effect. So we have used in the same manner we have done, and we have reached to, we have used WRF solar because it has a background climatology, the aerosol. And you see it is, I think, clear sky condition. And the correlation any, class 10 student can do it. It's like 0.99. So, but if you go to the, I don't know what it is. It is, so this is also, I think this is also clear sky. This is partially cloudy, okay. So when there is partial cloudy sky, you can see, we compared this data with IMD radiation data. And so the model sometime, comes down, falls. But more or less, the correlation will be not as high as clear sky. But see, at least it is capturing the, the trend. So, yeah, this is cloudy condition. This also looks okay to us. And so if it is raining, then, the model cannot capture the, so it goes absolutely. So I think I will stop. I will just put a summary that This 12-kilometer global high-resolution GFS, which is actually very, very well suited for Indian region. And this is presently being run in a deterministic mode, means there is only one model which is running and giving one prediction. But we are in the process. By 2018 June, we will make this model into an ensemble model. And by doing ensemble, we will be able to handle the uncertainty of the forecast even better. And what Dr. Wall was showing, that the spread. So that spread we will be able to calculate for this 12-kilometer model, as well as when this ensemble is used to a, is downscaled to site level. There also we will be able to provide the spread, and that is very, very important, because the spread only will be able to tell you the accuracy, or how much weight, or how much reliable is your forecast. Because you have, say, 20 members, and if the 20 members shows a very huge spread, it will mean that, within a family, the members are fighting each other. So you can say there is less peace, less homogeneous, so the less reliable, right? But if you find that even though a cyclone is coming, depression is coming, still your members are very close to each other, the spread is less. So you can conclude that this forecast is much reliable. And from that, you can actually calculate the probability distribution. And from there, you can actually say, okay, you can give a better guidance to the power sector or whatever it is. So we are in a process of doing that. But presently, with whatever computer capability we have, we are using it in single deterministic mode. Let's stop here and take any questions. Thank you.
Yeah, thanks a lot for the presentation of the latest development. I'm quite sure that the high-res GFS is a very good basis for including the indigenous forecasting system as well. So I think there are many questions concerning that. Yeah, please.
It's good that the Indian Meteorological Department gives rain forecast for various places on every day. Now that India is going renewable way, windmills are there from Kanyakumari to Jammu and Kashmir on the western side of India. Would it not be timely for Indian Meteorological Department also forecasting wind every day for states from Kanyakumari to Jammu and Kashmir? The western side of India has more windmills, more winds, and more wind generation.
So the point is that actually, if you go to IMD's website, you will see that the wind forecast is there. But here, I think what we are discussing is the wind at a very specific level and wind at a very specific site, right? You want wind at every 15 minutes, you want wind at 80 meters of height, and you want at the specific where your turbine is, right? Yes. So that forecast is a very, customized. It is a demand-based. Because in generating that forecast, you need a huge resource, because as I showed. Yes, but so that can be generated based on the specific requirement. Normal public, for the general public, so IMD's the mandate is to warn the general public, right? The society at large. So there, they don't need at 15 minutes. They don't need at 80 meter or 85 meter and so on. This is for a specific sector, for a specific purpose. So my point is, if this mechanism is established, right, that this sector, IITM, IMD, and the wind sector anyway, if we can build this mechanism, this is doable. So now we have achieved the tool, at least, into the 2017. where we can at least, provide as per the requirement. This can be customized and provided. 5 years back, this was not there. Now today, at least, we are in the positions. Yes.
One question there.
Not a question. I just want to add a point in this. I think, if I am right, that NIW site has a 20-meter wind speed is available, and this is in real-time data.
No. At NIWay website, we have wind speeds available at 20 meter for the rooftop aero generators. We also have wind speeds available at 50 meter, 80 meter and 100 meter level. And that is all for 10 minutes time average. But the point what is being discussed there is not the wind speed maps. What sir is asking is the 15-minute power generation prediction to the utility boards.
Yeah.
So what he wants him is that, sir, to add to your information, NIWay has already developed with the help of Vortex Spain. Dr. Kasturi Rangian has also helped us in that, and we have already gone ahead and prepared an indigenous model where we will be, now we have also tied up, Mr. Mathur was here with Rajasthan and Gujarat. We will be, sir, using this indigenous model for Gujarat and Rajasthan state. So for Tamil Nadu, of course, we are using the Vortex model. So we have done that, final resolutions of 4 by 4 kilometer. And we will be using the ISRO-SAC data. Rajkumar sir is here, and then we will trying to predict that by using what Dr. Waldi said, the blending the approach of the statistical and physical. All, sir, you need to take is that you have to take the real-time generation data. So right. Whether in your Maharashtra side have you taken?
Yeah, we have taken
controller data you have taken, or from the utility you have taken?
No, we have taken real time.
Real time from the controller, from the machine, or
from the machine?
So
we have this FTP,
So a good thing is if you talk to your utility boards in Maharashtra and get it from the feeder-wise generation data, that may help you to further fine-tune your models.
No, our submission is, this power is one part of the whole story. Our submission is that this is a national, huge resources have been put in generating this forecasting system at 12 kilometers, which is basically targeted to this type of applications. So whether it is wind or whether it is agriculture, whether it is forestry, and this data will not match any other data from anywhere in the world, because 2,000 automatic weather stations of IMD is getting assimilated. All the insect profiles are getting assimilated. So even if you compare this analysis with the ECMWF and NCEP GFS, this data you will find much better than those, because this regional data is not getting assimilated to the extent where it is going here. So whether you want to run Vortex or whatever model, in principle, if you use this as a boundary and initial condition, because it is an initial value problem, as I showed in the beginning of the slide, there is a higher probability that your forecast accuracy will improve in the short term. That is the submission. And then, of course, what he is telling, that is the next step. We can, of course, do that, power forecast,
So we will talk to you and then try to see what is your 12-kilometer model, and if that can help us in, improving that.
Yeah.
So that's a good idea. But all, sir, they are looking for is only wind speed, predictions. Our aim is to do a power, predictions. And we can add our power and then we can integrate the model. What is point, sir, is also correct, that Vortex Spain models and all, they do not take the Indian climatological and dusty environmental conditions as a spread out, what he was mentioning in our model. So if that they can help us, we
so
can
the moment you will see there is a cyclone coming, there is a depression coming, you will find that other centers will lag.
So that all
will not match.
The climatological conditions are being, inbuilt, and the historical data we are trying to take it from SLDC. So I think that way we can improve our accuracy levels. Yes, better outputs.
No, we are already in a process. I think Prasoon knows this very well. Yeah, so in our, now we don't have any 5-year plan, but we have the next 3-year plan. And in next 3-year plan, the Ministry of Arts Science has already put a very, promising project on solar and wind. And there they have included all the institutions like NIWay and so on. So we have already identified a site also where, like a super site, where they are going to put so many, instruments like wind lidar and sonar and things like that. And what we will actually, I was discussing with Dr. Giridhar that, see, what will be really good that in Niue you have so many wind towers, right, all across India. Now, if that data is, if it is quality controlled, if it meets the quality for this model, then we can even, for like a demonstration project, we can utilize this data in the initial condition to see how my low-level wind is getting improved by the assimilation of these data, and then we can go for a forecast.
To add to the information of the audience and as for your kind self, sir, NIWE has 822 real-time ranging from 50 to 120 meter met masts available with us, covering almost 27 states and 7 union territories under the National Wind Monitoring Program. And apart from that, we have some 1,000 plus wind mast stations, which the private measurement companies have done it, and we have vetted that. So they are all authenticated time series data of 10 minutes average, which is being stamped by NIWE. And for the benefit of the public, we have also placed on our website. If anybody wants to download the time series within, using a password, he can download. So that can be well shared with you if you can help us in improving the model. And the generation data is also not an issue. Now we are getting from 10 Jetco, we are getting from Gujarat, we will be getting it from Rajasthan and other states of renewable rich states as well.
That will be helpful to fine tune the model further.
So earlier what sir was mentioning, he was asking first question that what was our accuracy levels to sir. So I agree, sir, with you. In 12-13, when we started with Vortex, Indo-Spanish program, we were having the accuracy levels of 25 to 30%. And it was very, high, which was not at all in the norms of CRC. So, our people group team, they were working on mathematical models and then trying to bring it down. And trying, so then that way, we started. So that has to be reduced by the modeling as such, not by the mathematical equations. So that we will talk together and we will see what best can be the levels.
I think that's a very important discussion which is currently going on, but unfortunately we do not have the time to extend that. I think we all agree that it's very important to join all the efforts here in India in terms of modeling, in terms of the data and assimilating all the data NIWE has, and this is the same true for solar. Of course, these more than 100 measurement stations will provide excellent data, so providing them to the meteorological services also could significantly improve the forecasting. So I think that it's the work of the next month to force this discussion to such kind of an end. So I'm happy to have all the people here and being able to discuss that. So thanks for that.